Okay, Math 8 students, we are going to go ahead and move into lesson 5.3, linear relationships and bivariate data. Okay, so first of all, we should have reviewed the vocabulary. Bivariate data means that you have two variables. So that's nothing different than what we have been doing already, meaning that we've got an x and we've got a y. So bivariate data, two variables. So an x set of values, a y set of values. Our essential question for this lesson is how can you contrast linear and nonlinear sets of bivariate data? And the answer would be a graph of linear sets of data is a single straight line, right? Is a single line, whereas the graph of nonlinear data is not a straight line. So if it's linear, it's a straight line. If it's nonlinear, it's not a straight line. Pretty straightforward. And graphing will always be the easiest way to determine that. So we've got a couple examples here that we're going to look at, and the first thing that we're going to do is find the linear relationship. And to do that, what we're going to do is we're going to find the equation of each line and of each linear relationship. So we know these are linear, we know these will make a straight line. What it wants from the equation is it wants our slope-intercept form, so our y equals mx plus b, where m is our slope and b is our y-intercept. Okay? Slope, y-intercept. We also call this our initial value sometimes. And slope we also call our rate of change. So let's take a look here at number 1. And the first thing that I'm going to do is I'm just going to look at these points here on the graph. And it's a very common mistake, and I know a couple of us have made it when we've been correcting our work. It's come up in conversation. To make sure that you're counting the value of the units here on the axis, not just counting the number of unit itself. Like, so this is only 1 square, but this 1 square is 5. Same thing here, this is only 1 square, but this 1 square is 20. So let's go ahead and determine our points here, our x and y values. And this point is x is 5, y is 40. This point is x is 10, y is 60. This one here, x is 20, y is 100. And this last one here, x is 30, y is 140. Okay, so now that I have my points, I can choose any 2 points and find my slope. And I'm going to use that point slope, that rise over run, so y2 minus y1 over x2 minus x1, 2-point formula here. And it doesn't matter which points you choose. You can choose any 2 points that you want to. I'm going to go ahead and choose this, this point and this point. I don't know, just because I feel like it. So this is our, since we read graphs from left to right, this will be our x1 and y1, and this will be our x2 and y2. So y2 minus y1 is 140. You know what, I'm going to go ahead and write that down below where I've got a little more room. So 140 minus 40, right? y2 minus y1 over x2 minus x1, which is 30 minus 5. And so that leaves me with 100 over 25. And I can simplify that down. I can reduce that down to just 4, right? Because 100 divided by 25 is 4. So m equals 4. And you can use this on the graph too. You can always just count your rise over run, right? So I could have counted here. My rise from 40 to 60 would be 20, and my run is 5, right? So that'd be 20 over 5, which also simplifies to 4. So I could have picked any of these points and found the slope by just counting on the graph also. So now I've got my slope and I need my y-intercept. On a graph, the y-intercept, as we remember, if we follow that line, is where that line crosses the y-axis. So here's my y-axis, here's my line, and it crosses at 20. So when x is 0, y is 20. And I write this in this point form, this xy form, But that's not how you would identify B, right? So if this is my point, when x is 0, y is 20, that means that B equals 20. Not this right here, but B equals just this value. So I've got my M, I've got my B. I'm going to plug those into my y-intercept, or slope-intercept form. So y equals mx plus b. I'm going to plug them in, and I've got y equals 4x plus 20. Pretty straightforward there. So what if you are given, like number 2, you're just given a table of values? And this is a little bit of review from the last lesson, but you would find, things the same way. You have 2 points essentially that you're going to pick, and you can pick any 2 points because we need to find our slope, which is going to be y2 minus y1 over x2 minus x1. And you can pick any of these. These are essentially just ordered pairs. They're just points on a graph, and so you can pick any 2 that you want to. I'm just going to try and keep it simple here. I'm going to pick these 2 right here. So this would be my x1, my x2, my y1, and y2. And I'm going to plug those into my equation. So y2 minus y1, 3,600 minus 480 over x2 minus x1, 15 minus 2. So I've got 3,600 minus 480. Let the bell go. Over 15 minus 2. So what I've got here is 3,120 over 13. And now I can simplify this by dividing. So 3,120 divided by 13 is, I'm going to work that out here real quick, 240. And so that equals my slope. Okay? So I've got my M, I've got my slope. Now I need to figure out my y-intercept. So there's 2 ways that I can do this. Okay? So if my slope is 240, that means that's my change in y is 240 and my change in x is 1, right? So I can work backwards on my table to determine my y-intercept, and that would be minus 240, right? Minus 240, and I'm just going to do a little graph over here so you guys can see that. Let's see if I've got enough room here. So what I'm trying to do is I'm trying to get where x is 0 to figure out my y value, right? So if I've got 2 here and 480, my change in y is 240, so I can work backwards. And every time I subtract 240, right, this would be 240, and I'm going to subtract 1 for my x. So minus 1, and that's 1. Okay, we're almost to 0. So minus 1 again, that gives me 0. Minus 240 again, that gives me 0 here. So I have got a 0, 0 pair for my y-intercept, which means that my line goes through the origin and I don't have a y-intercept, I don't have a b value. My b value is 0, so b equals 0, which means when I write my equation, my y equals mx plus b, it's going to look like y equals my slope, 240, right? X, and then I could put plus 0 because that's what my value is, or I can just leave that off. And that's still correct. So my slope here, my equation here now is y equals 240x. So the other way that you could have determined what the b value is you could have had your equation here, y equals 240x plus b, and plugged in 2 of your x and y values and solved for b. We've done that before, but we're not going to do that this time because working backwards in the table is a good way, is a good strategy as well. Okay, so the second thing that we've got to look at here is making predictions. So Paulina's income from a job that pays her a fixed amount per hour is shown on the graph. So she makes the same amount of money per hour, every hour. Use the graph to find the predicted value. So they were kind enough to give us a graph again. So what we're going to do with this graph is we're going to identify these points that it's given us. And it looks like each of these is worth 10. And each of these is worth 1. So what I'm going to do is I'm going to find points that have clear intersections at an x and y. They're going to be easier to determine than like this one right here, which is kind of in between, and it could be 45, but maybe it's 46. I don't know. So I'm going to pick these values right here that have clear intersection points on the graph, so I can get a clear point value. So this one is 4 and 60, and this one is 6 and 90. Okay, so now that I've got 2 points, I'm going to figure out my slope. And I'm going to plug that into my equation, y2 minus y1 over x2 minus x1, right? So I've got y2 minus y1 over x2 minus x1. And so what that looks like here is this is my y2, this is my y1 because we read from left to right. So I've got 90 minus 60. Oh, not 60, that should be 6. You guys didn't. Anybody catch that error there? This is actually 6 and 90, not 60 and 90. So 6 minus 4. So what I've got here is, now I'm going to simplify this. I've got 30 over 2. So in 2 hours, she makes $30. Or in 1 hour, she makes $15. So what it wants to know is the income earned for working 2 hours. Well, we actually figured that out already right here, right? So in 2 hours, she makes $30. Make sure you use your dollar signs because we are talking about money. And then since we know what her hourly rate is for 2 hours, we know what her hourly rate is for 1 hour, we can predict what the income is for working 3.5 hours. And we do that by plugging that into our equation. And she's starting at 0, so we don't have to worry about any y-intercept. We just have y equals, so y being the total amount earned, her hourly rate, 15, times the number of hours she works, which is x. So what we're going to do is we're going to plug in that number of hours that she works, 3.5, and we're going to have y equals 15 times 3.25, which is going to give us our total value for 3.25 hours. So 15 times 3.25 gives us 48.75. So in 3 hours, 3.25 hours, so in 3.25 hours, she makes $48.75. And again, make sure you're using that dollar sign because we're talking about money. So we're going to make an even bigger prediction now because we've got this equation. We can predict any amount earned for any number of hours worked. And we want to find the total income earned for working 5 8-hour days, all at the standard rate. So her standard rate being $15 an hour. So 5 8-hour days. So let's figure out how many hours that is first. And we can, 5 times 8 is what? 5 times 8 is 40. So a 40-hour work week. So 40 is going to be our x value. We're going to plug that in to our equation, y equals $15 per hour times 40 hours. And we get y equals $640. Wait, that doesn't seem right. Let me try to double check that. 15 times 40 is, oops, that's right, $600, which makes more sense because 15 times 4 is 60. Add a 0, that's 600. So for a 40-hour work week or 5 8-hour days, she makes $600. So real world application here, guys. If you are working a job and you have an hourly rate, you can figure out how much you make after a certain number of hours if you know how much you make per hour. Okay, so those are the two main things that you'll be doing in lesson 5.3 is analyzing linear relationships and nonlinear relationships. So going back to that essential question, if it's linear, it's going to make a straight line. If it's not going to make a straight line, which means if you don't have a graph and you only have a table, you're not going to have a constant rate of change. Okay, common error would be that you have different values, but they all simplify to the same rate of change, but you don't simplify them, so you don't see that. So make sure that if you're getting different values here on the table, make sure they don't all simplify to the same rate of change first. If they don't simplify to the same rate of change, then you do not have a constant rate of change, and you do not have a linear relationship. And we've talked about that before, but you will definitely see some of those in your practice for this and your assignment for this one. And then you'll be looking at writing equations from tables and graphs, which is not new. And then you'll be looking at making predictions based on finding equations from graphs and tables. So all good stuff. There will be a second video posted after this that goes a little bit more in depth in comparing linear and nonlinear graphs and equations. You are welcome to watch that. It's the notes on the back side of this page. It is bonus. I do recommend watching it, but you do not have to. All right, if you've got questions, make sure you bring them to class so we can talk about them. If you are not understanding, or if you are understanding, if you want to do more, there's always extra practice that you can do. All right, guys, I will see you on the flip side.